Hi guys, and welcome to Symbol Tech Working Bench. This time with part 2 about H.H. Scott vacuum tube amplifier. So far I did all the connections back to this amplifier, and I don't did yet the modification for the original tubes like in the schematic. I just keep the old ones that they were here inside before. So these one are the ones that someone modified. Let me adjust the camera. So these are the tubes which are now inside. I don't know if you can read, are the Russians one, 6P3C. So the new tubes that they were gonna go inside are on this box. So let me show you which one are the new ones. So this one they were gonna be the 12AX7, which are the front ones, the input. And then we have a new rectifier tube that we're gonna replenish that one over there. And then we have the 4 power tubes that they are the 7591A. And between this one and the Russian ones, there is slightly different pin out, so that's why I need to do some modification on the soldering the pins. But now, if it's everything soldered for these tubes, let's give a try, hook up some speakers and see how that sounds. I already connect these speakers to it, and the power cord also is connected. I also bring the signal wire in, so let's turn on and see what's going on over here. I'm gonna put the volume all the way down, and let's wait that the tubes they come on. We have the tubes already on, and we have this badly hum. So this hum is not the earth one. If I increase the volume, see, you're gonna notice this is the earth hum. So we have a hum that I need to understand from where it's coming from, that hum. Let's play anyway a song to see what's going on over here. Definitely sound nice, but I have this hum that I need to understand from where it's coming from. I think it's related to some power supply, I believe. Let's try another brand. Yeah, definitely sound nice, but I need to understand what is that hum. So let me hook up the oscilloscope. It might tell me, the oscilloscope, the frequency of that hum. So everything is connected. The oscilloscope, the amplifier here, power is in, I have the dummy load connected and the probes to it. So let me turn on, but first let me tell you about my sponsor of this video. Owen is a company manufacturing test and measurement equipment and other more products, and they operate since 1990. Team products are oscilloscopes, waveform generators, digital multimeters, spectrum analyzers, and more other products. And if you want to know more about the product, please check the link on the description below. Now let's turn on this one and see which frequency has that noise. So now the tubes are warming up. Looks like it's picking up something of 50 Hertz there. So I say that is related to the power supply. And I can see the waveform is not properly the 50 Hertz one is really something not how should be. So let's see if we can zoom in a bit. So I can see here there's a lot of noise coming in that frequency, and looks like it's telling me that the frequency here is 97 Hertz, 100 Hertz, so it's something related definitely with the power supply. If I turn off the volume, and I need to bring the trigger more down, be a bit more stable, but if you can see, it's a really strange waveform, so I need to understand what is that. And for this one we need to do some measurement definitely, so I'm gonna bring my multimeter to measure something. So I'm going to use my Owen XDM 1041 for these measurements, and I can say I'm already using for a while and I'm really happy with the performance and how do the measurements. And if you are interested in one, check the link on the description below. So now let's see the voltage here. So I'm doing first the AC voltage to understand how many voltage I have on the transformer, and let's have a look. But first let me turn on, because I'll not have any voltage if I don't turn it on. So now it's on, and let's have a look. It says that I have 361 volts straight away from the transformer. 361 volts, yeah. So let me take a paper to write down these things. So I say that I have the 361 volts for the plate voltage. So this is plate voltage. The AC, right? The AC I'm measuring now. So AC. Now what I want to measure is the heating element voltages. So I have 5.09 over there. 5.09 is telling me. So then I have the 5.09 volts for the heating element. And then I still have one voltage over here, which is the heating element for the tubes, which is these two pins, which is 6.1, and it should be 6.3, by the way, 6.1 volts, same heating element. And I still have a voltage over here, which is for the negative voltages, which is 36.9 volts. So why I measure all these voltages? Because I measure it without load, so that properly the transformer is not under stress at all, because it's just plug it in and just put the output power what are the windings. Because this is the rectifier tube, and now I'm gonna install it back, and I'm gonna turn it on, and I'm gonna measure again the same voltages, and if there is drop, definitely transformer is not power enough to supply the power to this amplifier. Okay, so I installed back the rectifier tube, so let me turn it on again, and now it's on. So let's have a look now, the same measurements over there. So this one is the first one, so let's have a look. I'm measuring DC, I need to measure AC. So let's measure the AC over here. So you can see, without any load we had 361, now we have only 341. So 361, now it's 341. So definitely we have 20 volts dropping on here. So this means transformer doesn't have enough amps to supply that power. Let's check also the voltage on the heating element, which it was this one. Heating element also from 509 dropped to 4.7. So also here we have a voltage drop which is quite high. Let's have a look also that voltage over there, the 6.1, which it was this one here, 5.99. So from 6.1 we have 5.99, and then let's see this, the voltage over here, so 35.6. So from 36.9 we dropped to 35.6. So this means the primary of the transformer is not, the winding is not made with the thickness wire in order to can cover all the outputs and to supply the power that the amplifier needs. So yeah, I think the noise is because of that one. Okay guys, in my opinion, the hum is coming from the transformer because it's struggling to supply the power for this amplifier and is not powerful enough. We saw that drop on voltage straight away from the transformer, not from the capacitors. So this means the transformer is not powerful enough and cause, in my opinion, the noise. Please let me know in the comments below your thoughts and your ideas. What can generate that noise? I'm gonna wait your comments down below. Then I draw this transformer because definitely on my calculation for this amplifier we need a 450 VA at least transformer to supply the power. And I draw the primary, secondary with all the voltages that I need, with all the amps that I need, and my friend Vishal, because this amplifier belongs to Vishal, he's looking for a company that they can build the transformer. You just give them the drawing and the voltages and how many VA you want, and they're gonna build for you. So please stay tuned, subscribe, activate the notification bell, because as soon as we're gonna receive the new transformer, we're gonna come out with the part 3 of this project. If you enjoyed this video, please give me a like, and until the next video guys, bye bye and have a good day.